Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. This is part 5 of sequences and series. And on this video, we're going to talk about arithmetic series. Let's start. For an arithmetic sequence with the first term A and the common difference D, the sum of the first n terms, Sn, is given by n by 2, 2a plus n minus 1 times d. Now you have to remember this formula, all right? S of n is the sum of the first n terms. In part 2 of the video, we gave it a special name. The sum of the first n terms of any sequence was called the nth partial sum. For an arithmetic sequence, the sum of the first n terms, the nth partial sum, if you know the a, the first term, and if you know the d, the common difference, then the nth partial sum, the sum of the first n terms, is given by this particular formula. It's worth remembering. As I said, S of n is equal to n over 2 times, into brackets, 2a plus n minus 1 times d, all right? Now, this nth partial sum is also commonly known as series, okay? So if the sequence, the original sequence is an arithmetic sequence, that series, the corresponding nth partial sum is called an arithmetic series. You'll come across that word. I thought I'll clarify that part also, that it is the same idea. The nth partial sum is also known as the series, okay? Keep that in mind. Okay, let's take some examples to understand how to use this particular formula. So we have got this question which says, for the given arithmetic sequence, okay, only if it's given that it's an arithmetic sequence, then that formula is valid. You'll have a different formula for different sequences, right? So for a given arithmetic sequence, the sum Sn, the same thing as the nth partial sum, to the requested number of terms is what we need to find out. So we need to find out Sn for n equals 12. That means the 12th partial sum, and the sequence is given to us as 4, 3, 2, dot, 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 dot. So let's see how to do it. The first thing, as I always encourage my students to do, is that first write down that this is an AP, arithmetic progression, arithmetic sequence, just another word, so that you know that the formulas that you're using are applicable, because you know that this is an AP. Even though if it's given in the question, I think it's a good habit when you're writing the answer, just make sure that you've also written that first statement. And you know that this is an AP, and you can write down from the question what's given, all right? So you know that that's the terms of the sequence. You can write down A, the first term is 4, and the common difference D. Well, how do you find the common difference? Second term minus first term. Third term minus second term. Well, second term is 3. First term is 4. 3 minus 4. I'll write it down. Okay. 3 minus 4 is a negative 1. That's going to be, it's a negative 1, sorry. It's a negative 1. Your common difference is negative 1, and your A is 4. The first term is 4, and the common difference is negative 1. And you can check that, okay, that the difference is constant throughout, okay? So even 2 minus 3 is a negative 1, so you're good to go. And we want to find the sum of the first 12 terms. So let's make use of the formula. S12 is what we're looking for. It's n over 2. N is 12, so it's 12 over 2 into big brackets, and 2 times a, which is 2 times 4, plus n minus 1. 12 minus 1 is, let me write it as 12 minus 1 first, n minus 1 times the d, which is a negative 1. Can you see with this color? All right, here we go. I'll make, and then close the bracket, okay? So that's n over 2, 12 over 2, 2a. Be careful of that. 2 times a plus n minus 1, 12 minus 1 times the d, which is negative 1. Now it's just about simplifying this. You'll get this as 6, and 4 and 2 is 8, plus this is 11, and that's a negative 1, so it should be just a negative 11, negative 11. And then when further simplification, this is 6 times negative 3, which means the sum of the first 12 terms of this arithmetic progression is a negative 18. Cool. Let's take another example, okay? Slightly different kind of an example where you've got decimals. Can you see that? 2.9, 3.6. I'll write down the question here, okay? The terms of the sequence at least. So I'm just going to write down the terms of the sequence as 2.9. I think that was the first term. And then it's 3.6, 4.3, 3.6, and then 4.3, and then dot, dot, dot. And they've asked the sum up till the 11 terms, n equals 11, all right? So we want to find out S11, okay? Clearly, it's an arithmetic sequence as it's given, so you can write down this is an AP. arithmetic progression. Okay, and what's the common difference? The first term, of course, is 2.9, and the common difference we said is the second term minus the first term. Okay, third term minus second term. It's constant. So 3.6 minus 2.9 should be 0.7. Okay, and we can check that whether it's the same thing for 4.3 minus 3.6. It is. Okay, so 4.3 minus a 3.6 is also a 0.7. You can just check with one number that's okay, one set of numbers. That's make sure that it's the two consecutive terms. All right, so the second term minus the first term, the third term minus the second term should give you the constant difference. So we say D is equal to 0.7. Now that you've got your two key elements for the formula, you can make use of the formula and say, okay, S11, which is asked in this question, I'm going to continue the solution here. S11 is going to be equal to N over 2. Let me write down N over 2, 11 over 2, open the big bracket, the rectangular bracket, 2 times A, 2 times, it was 2.9, 2.9 plus N minus 1, I'll write it as 11 minus 1, times the D, which is 0.7. 0.7. Can you guys see this? All right, here we go. Now it's about simplifying. Be careful with the decimals, okay? We can leave this as 11 over 2, and 2 times 2.9 should be 5.8. 2 and 9 is 18, yeah, that's right. And this is 10 times 0.7 should be just 7. And when you can further simplify it as 11 over 2, this is a 12.8. You can cancel that 2 with the 12.8 and say that this is going to be 11 times 6.4. Okay, and then when you multiply, you'll get 11 times 4 is a 44. 11 times 6 is a 66, plus that 4 is a 70. So that the sum of the first 11 terms of this arithmetic sequence, whose first term was 2.9, common difference was 0.7, the first 11 terms sum up to 70.4. Okay, there is also another version of this formula to find the sum of the first n terms of an arithmetic sequence. So if you're given the first term and the last term, if L represents the last term of the sequence, so if you know the first term and the last term, let me write down, this is the last term and this is the first term. So for an arithmetic sequence, if you know the first term and the last term, there is another formula for this sum of the first n terms. Okay, it's given by n over 2 and it's a plus L. Remember here it's a plus L. Okay, be careful of this. That's why I said that when we were using this formula, it's 2a here and here it's just a. N by 2 outside the bracket, but it's a plus L. So if you know the last term, use this particular formula. If you don't know the last term, use this particular formula, as long as it's an arithmetic sequence. Let's take an example where we can use the second formula. Okay, so this is a question where you've got the sequence given as 5, 4, 3, all the way up till negative 15. And the question is to find the sum of the following sequences. So we don't know n, we don't know how many terms are there, that's number one, but we know the first term and the last term. So the challenge is how many terms are there, we need to figure that thing out, and we can make use of the first term and the last term after we found out how many terms of the sequence are. So it's an interesting question. I'm just going to write it down here. So this is question 3, and the sequence was 5, 4, 3. So we've got 5, 4, 3, and all the way up till a negative 15. We know that it's an AP. We don't know how many terms are there in the sequence. That means we don't know n, but we know what the first term and the last term is. Let's see how to do this. All right, so we can write this thing down as, again, this is an AP, and you can write down the first term is 5, the last term L is a negative 15. All right, now we have to recall the formula for the nth term. Because it's an AP, the nth term is a plus n minus 1 times d. We saw this in part 4 of the series on sequences and series. If you haven't seen this formula, please go ahead and take a look at it. It's on part 4. I'm going to link all those videos in the description box below. This formula gives the nth term or the general term for any term of an AP, of an arithmetic progression. We can make use of this formula for the general term to find out what the value of n is when the term is negative 15. The value of the term is negative 15. What is the value of n? All right. So how do we do that? Let's check it out. Okay, so u of n is the term value, which is negative 15 in this case. A, we already know, is 5. N minus 1, we just leave it as n minus 1. And d, we can look at the terms and say, okay, 4 minus 5 is a negative 1. 3 minus 4 is a negative 1. So d is negative 1. We can make use of that idea also and say, okay, d is a negative 1. And using that, we can then solve for n and say this is a negative 15 and this is 5. And we've got the negative n plus 1. So that this is going to be negative 15 equals 6 minus n, or negative 15 minus 6 is going to be a negative n. Well, n has to be positive. We can change the sign. So n must be equal to 21. Can you see that? So it's the 21st term of that sequence whose value is a negative 15. And now we can make use of that formula, the first term and the last term, involving the first term and the last term, and we know n, to find the sum of the first 21 terms of this arithmetic sequence. We can also make use of that first formula that I showed you, but because we know d and we know a and we know n, but let's just try with the second formula that I showed you. Okay, so this is the first 21 terms. We say S21 is going to be equal to n by 2, 21 by 2, and a plus l. A was 5 and l was a negative 15. Okay, can you see this? All right, so that becomes 21 over 2. 5 and negative 15 is a negative 10, and this becomes 21 times a negative 5, which is a negative 105. Negative 105 should be the sum of the first 21 terms of this arithmetic sequence. Whose first term was given to us, last term was given to us. We could deduce the value of d, but we were not given the number of terms. And we use the formula for the general term to calculate the value of n. You could have then used either of the two formulae, Sn is equal to n by 2, 2a plus n minus nd, or Sn is equal to n over 2a plus l to find S21, which is the sum of the first 21 terms. Now let's take a look at another question, slightly different question, okay? And this says that the fourth term of an AP or an arithmetic sequence is 5. So we write down what's given, okay? We say that this is an AP, and they're saying that the fourth term, U4, is 5, right? Okay, while the sum of the first 6 terms, that means S6 is 10. Cool? So they've given the fourth term and they've given the sum of the first 6 terms. And they have asked us find the sum of the first 19 terms. The question asks us S19. And how do we solve this question? Well, let's make use of both the formula. Like we did in the earlier case also, we saw that the formula for the general term of the arithmetic progression was used, and the formula for the sum of the first n terms was also used. Likewise, in this particular question, because U4 is given and S6 is given, we'll have to use that. And so when we use that, we can say, well, U4 is 5, so 5 must be equal to A. We don't know what that A is. A plus n minus 1. N is equal to 4 here, so n minus 1 is 3 times the d. We don't know what A is, we don't know what D is, but we know that the value of the fourth term is 5. So 5 is equal to A plus n minus 1. 4 is n, so 4 minus 1 is going to be 3. So we get an equation in A and D. Let's mark it as equation number 1. All right, can you see this? Cool. Let's do the same thing for S6 is equal to 10. Obviously, it's a different formula. S6 is the sum of the first 6 terms. So we can write that as 10 is equal to n over 2. 6 over 2 is going to be 3 into brackets 2a. We don't know what the a is, plus n minus 1. All right, that 6 is n here. So that's going to be 5 times d. And that's going to be our equation number 2. I'm going to simplify this before I label it as equation number 2, so that this is going to be 10 is equal to 6a plus a 15d. So what we have are two equations in a and d, and we can use any of the methods of solving linear equations in a and d, like simultaneous equations, and then we'll find out a and d, and using those values of a and d, we'll find out what the sum of the first 19 terms is. That's going to be our approach. So before we do that, what I'm going to do is that this equation number 1, I'm going to multiply it by 6, because I'm going to use the method of elimination to eliminate a. What I'll do is that I'm going to multiplying equation 1, by 6. All right, and what are we going to get? So we'd get 6a plus 6 and 3 is 18d. 6 and 5 is 30. I'm going to call this equation 1a, because it's just equation 1 multiplied by 6, all right? And equation 2 is 6a plus a 15d is equal to a 10. That's my equation 2. Now I'm going to subtract these two equations. Can you see this? All right, subtracting the two equations, we'd get, this gets knocked off, and we've got a 3d is equal to 20. Even if it's a fraction, My tip is leave it as a fraction. Okay, d is equal to 20 over 3. Just leave that as a fraction. Don't try and make it a decimal. It'll just get messy. So leave it as a fraction and don't be afraid of working with fractions. Now, once we know the value of d, we can substitute it in any of the equations. So what we'll do is that I'm going to substitute in equation 1, substituting in 1. This is becoming more like a lesson on simultaneous equations, right? So you got a plus 3d is 5. A plus 3d is equal to 5. And so a plus 3 times the d we just found out as 20 over 3. So that is going to be 20 over 3. Now you can see that why I said you can leave it as a fraction. Sometimes these questions, I think it's just, manufactured in such a way that, we get confident using fractions, but at the same time, the numbers become friendly, even though they don't seem as friendly initially, right? So we have a is equal to 5 minus 20, or a is a negative 15. So we found out the value of a as a negative 15, and we have the value of d as a 20 over 3. And using these two values, we can find out the sum of the first 19 terms. Let's do that quickly. All right. So S19 should be equal to 19 over 2, n by 2 times a, which is going to be negative 30, plus n minus 1. N is 19, so that's 18, times what? What's d? D is 20 over 3. Again, like I said before, it might seem unfriendly before, but now as you can see that 3 very nicely can cancel with that 18. And so when we simplify this, you get 19 over 2, and here we have a negative 30. What do you have? 6, and that should be 120. Okay, and 19 over 2. This is going to be 90, I believe. 90, yeah, that's right. And so that can further be simplified as 45. So we got 19 times 45. Let's work that out quickly. We are doing this without a calculator. So 9 and 5 is 45, 36. So that's, and this is 5 and this is 4. You should get this as 855. So the sum of the first 19 terms, let me write it down first, 855. The sum of the first 19 terms of this arithmetic sequence that was given to us. What was given actually? They gave us, some information about the arithmetic sequence. They said that the fourth term, I believe, yeah, the fourth term is 5. The sum of the first 6 terms is 10, and we had to make use of the 2 different formulae to find out the sum of the first 19 terms. We are going to continue our discussion on sequences and series in the next video. If you found this useful, please do not forget to like, share it with your friends, and please subscribe to this channel. I'll see you in the next one.